Hi, hello, Jai Jagannath. I hope you all are good and prepare well for your exam. Today's topic is principle of NMR spectroscopy. So the principles of NMR spectroscopy comes from the spin of a nucleus. The proton present in the nucleus and the proton is spinning along the axis and around the axis. When the spinning takes place, the proton acts as a magnetic bar. So, if the proton is present in a external field or without external field, here there is two possibility. If the proton is in a without external magnetic field, then the protons are in random direction and the nuclear spins are also in a random in direction. But when some kinds of magnetic field is applied to the proton, like B0 magnetic field is applied, here is the north pole and the south pole, and magnet is present, the proton are aligned to the magnetic field or opposite to the magnetic field. Here it is aligned to the magnetic field and here opposite to the magnetic field. The protons which are aligned to the magnetic field, having low energy and parallel spin. Also, the protons which are opposite to the magnetic field having high energy and anti-parallel spin. Okay, so the first one is the proton act as a magnetic bar, and when the proton present in external magnetic field, then it is act as a it shows against to the magnetic field or aligned to the magnetic field. But when there is no external magnetic field is applied, then the protons or the nuclear spins are random in direction. Okay, the next one is precessional motion. So what is the precessional motion? So the proton, when the protons are in external magnetic field, it shows some kinds of characteristics which is known as precessional motion. In precessional motion, the protons absorb some kinds of frequency, and here if it is the proton, then it absorbs some kinds of frequency, then it revolves like this and like this also. Okay, if we draw, then here is the proton, spins like this. If it absorbs some kinds of frequency, which is also known as precessional frequency, and creates a precessional orbit, and it also revolve like this and like this also. Okay, so where does the precessional motion comes from? When the proton is showing some kinds of precessional motion, and it is due to the interaction of the spin and the gravitational force of the earth. Which the interaction of the spin and the gravitational force of the earth is also known as the gyroscopic motion. Is also known as the gyroscopic motion. And when the external magnetic field is applied and they show parallel spin or anti-parallel spin, or low energy or high energy, or it may be aligned to the magnetic field or opposite to the magnetic field. So it is the aligned to the magnetic field means the protons aligned to the magnetic field is not similar to the protons opposite to the magnetic field. Hence, some kinds of magnetic dipole is arise. Magnetic dipole is arise. And the energy of the orientation of magnetic dipole is represented as del E, which is equals to h mu. Here h is the Planck's constant and mu is the frequency. Okay, and the next one is precessional frequency. The spinning frequency of the proton will be same. The spinning frequency of the proton will be same, and the precessional frequency, which is also denoted as mu, is directly proportional to the magnetic field, that is B0. Okay, and when, if the radio frequency energy is, it means some kinds of radio frequency, some amounts of radio frequency is applied, then one energy transfer is possible, means del E is occurs. Okay, so when some amounts of radio frequency is absorbed by the protons, and also we know as this, when the spinning takes place in the presence of magnetic field, the precessional frequency also occurs. So the amount of precessional frequency when equals to the radio frequency, then the transition takes place from the lower energy state to higher energy state. So here is the proton. If we represent it like this, the transition means the proton absorbs some kinds of radio frequency, and this radio frequency is similar to the precessional frequency, then the transition takes place. And the transition takes place from the low energy state, and as we studied before, low energy state means parallel spin, and parallel spin means aligned to the magnetic fields. Hence, the parallel spin means value is plus up, and for the, and means the value of I is minus up and the value of I is plus up. So the transition occurs from the plus half spin to minus half spin. Okay, or like this to this. So this state is known as low energy or stable state or alpha spin state. The transition occurs between alpha spin state to beta spin state. Clear? Here the magnetic field is applied. When the magnetic field is in an external magnetic field, when the radio frequency is absorbed by a proton, and the radio frequency is similar to the precessional frequency of the proton, then transition takes place from the lower spin state to higher spin state. This is also known as alpha spin state, and this is also known as beta spin state, and the I value is minus up in the beta spin state, and the I is plus up in the alpha spin state. Okay, in the beta spin state, this is having high energy and unstable state, and also against the magnetic field. Okay, where the spin returns to the ground state, then the absorbed radio frequency is also emitted. Means beta spin, when it returns to the ground state, then some amounts of radio frequency is emitted at the same energy or same frequency level. So the emitted radio frequency signal that give the NMR spectrum. Here it is the emitted frequency, and this emitted frequency gives the NMR spectrum, and the NMR spectrum is plot. The spectrum graph is intensity versus frequency. Okay, so the graph plot in between intensity versus, or the intensity of the NMR signal versus the magnetic field or the frequency, and the graph are like this also, sometimes like this. So here all about the principles of NMR spectroscopy. If we quickly discuss the principle of NMR spectroscopy, when the protons are in the external magnetic field, the spins are, or the protons are aligned to the magnetic field and opposite to the magnetic field, and in the presence of external magnetic field, some characteristics or some motions are created, or when the protons absorb some kinds of frequency, then precessional motion, which is due to the presence of gyroscopic motion, the interaction between the spinning of the proton and the gravitational force of earth. And when the aligned to the magnetic field, the proton aligned to the magnetic field is not equal to the opposite to the magnetic field, then magnetic dipole arises. When the magnetic dipole arises, then the energy orientation is known as del E. Del E is equals to h mu, and the precessional frequency is also represented as mu, and mu is directly proportional to the magnetic field. The precessional frequency is directly proportional to the magnetic field. When the radio frequency is observed by the proton, and the precessional frequency present in the proton, the precessional frequency and the radio frequency are similar, then the transition takes place from the lower spin state to higher spin state, which is also known as beta spin state, alpha spin state to beta spin state. Okay, so when the beta spin state means the spin returns from the higher state to lower state, then some kinds of frequency is emitted, and this frequency shows some signal or NMR spectrum, and the NMR spectrum graph is plotted in between the intensity of NMR signal and the magnetic field, which is known as frequency, and the graph is shown like this. Thank you, students. That's it for the today's class. Next we will discuss about the signals of the NMR spectroscopy. Thank you.